What's up, ladies and gentlemen, YouTube, everybody out there? This is Philip20 today, and you can see currently that we are not 357 Magnum no more. We're 375 Magnum. So we used some kilowatt hours to heat the house, and you know, I had to heat the house. I can't keep going without heat. So I wanted to go ahead and explain to you that I have not turned the inverter off, and I'm running all of my circuits solely on the inverter, except for the heat pump and the dryer and the stove. Okay, now those three things was the most difficult to run off of solar, so I didn't include them into the panel that I built for the solar array. So we got to look at it like this. How important is it to run everything off of solar? Well, it's very difficult to move heat around, especially when you can't start the compressor for the unit. Now, the unit is a 3.5 ton unit outside, so it uses a lot of power. Let's just get out of that and look at it like this. You got to take consideration, it's about 12:30 right now, and we have used the heat pump for about 1 day and 2 hours or so, or 1 day and 4 hours. I forget what time I came out and turned it on yesterday. But we're going to take a look at the indoor stuff. Our charge controller currently has at 1220 7.4 kilowatt hours of power. We are manufacturing 2,800 watts or so. We have 52.9 amps coming in, and let's take a look at how much power the house is consuming. And I'm going to show you something that's kind of interesting. Okay, so we've got a battery percentage of 88%, and we are charging 111 watts. We are in bulk MPPT. Okay, and we're consuming 2,700 watts right now. And the reason why we're consuming 2,700 watts right now is because I've got a wall heater plugged in to, you know, test the load of the Magnum inverter, testing the classic charge controller. We're trying to put a large load on the system, that way it stays in bulk and stays out of float for now, because right now we are still manufacturing less power with more solar panels than what we manufactured in the spring, with 750 watts less of solar panels with this charge controller. So I've seen this charge controller maintain 2,880 watts previously. That's the maximum at 24 volts. And when I switched to 48 volts, I switched the wires, I switched the inverter. It's all switched over to 48 volts. The battery bank is switched over. Instead of running 24 volts, now we're running 48 volts. So some people ask that question. I'm just trying to clarify it, that way everybody knows. This system was running 2,100 watts after I put the Whiz Bang Jr. in, and I don't know why, but after I put that in, it kind of backed off to and from 96 amps or so to like 88, 85 amps at 24 volts. But as looking here, it never did reach above that mark that I was talking about. So in all real world perspective, I think I should see about 3,000 3,600, 3,500 watts on a continuous run when we got this kind of sunlight. I mean, right now we got some really nice sunlight outside. So, and there's no clouds. I mean, it's totally cloudless. So, in this perspective, it should be running at full because we're in bulk, of course. We're outside of absorb mode, and we are trying really hard to, you know, run this classic. Now, before, this classic would be so hot I couldn't touch it, and the turbo fan would always run. But now that it's 48 volts, it's not hot compared to previously. I would say it's maybe 100 degrees right here. I always show you the temperatures. In this app, it shows me all the temperatures. So the FETs are 129 degrees Fahrenheit. I used to see them at 190. And the PCB is 121 degrees Fahrenheit. I used to see it around 180, 170. And the Whiz Bang Junior, it never goes up or down. It stays about the same. So you can see, you know, the temperature difference under full load conditions, that the temperature is drastically lower compared to what it was. I would like the fan to come on and, you know, remove more heat. I wouldn't mind it to come on immediately. I wish there was a setting that I could set it up that would turn the fan on, even keeping it cooler, even though it's kind of loud. I would rather have the fan running and keeping it cooler than it being loud. I don't really care. I can replace the fan when the one goes bad or something. But you get the picture, you know. So let's go and see why we're in bulk mode. Now this is why we're in bulk mode. We have a heater. I just turned it on. It's still probably not real hot. It's warming up, but it's not real hot yet. And this heater is right in front of one of the returns to the house. Sorry, this room is not finished, so if it looks like the return grill is kind of halfway hanging out, because it is halfway hanging out. And for instance, here's a hole in the sheetrock I haven't patched yet, because this room hasn't been finished yet. So, I mean, you can see we've got the heater running. It's running at maximum output. We're going to take a look and see how much power this thing is actually consuming. Our house is currently consuming 2,500 watts or so. 2,629 watts. Okay, we're going to flip these switches off. And that's going to back down to around 1,000 volts. Look at that, 1,500 watt heater. Okay, and then we're going to put it on low. So we got a low setting there. Alright, now we're back in bulk mode. We went to absorb mode as soon as we turned that off. We're back in bulk mode. Nope, it hit absorb again. So the heater is now consuming, I don't know, maybe one of the refrigerators turned off. I'm not exactly sure what's going on, but let's turn it off. Now it's at 546. Apparently that's what happened. 500 watts. Let's turn it back on. Low. That's the low switch. Now it's at 1,245 watts. So it's about 750 watts. And then we can put it on medium. Let's see what medium is. Now medium setting, you're going to bring it up to 1,328 watts or so. It's not a big difference between low and medium. And then high, with both switches on, that's going to take it out of absorb mode and put it back in bulk. And now we're at 2,600 watts. So apparently a refrigerator or something else turned off. So I'm not exactly sure what it was, but it turned off. So, you know, we're pulling 2,000 watts straight out of the wall, and we're trying to heat the house a little bit with it. I mean, you know, it don't hurt to have a little bit of heat. So whenever the fan turns on in the unit right there, when that fan turns on with the heat pump, That's going to help heat some during the day. But I want to take load off of the inverter. Okay? And with the DC elements, I can do that. I can take the load directly off of the inverter. I cut out the middleman of wasting power through the inverter, which is 6% of, 1,500 watts is a good amount of percentage. So we got to try to take the load off the inverter. That inverter needs to run everything in the house without, problem. And my biggest issue is the microwave and coffee pot and washing machine, the dishwashing machine. The regular washing machine don't use hardly nothing compared to, the dishwashing machine. The dishwashing machine is incredibly inefficient because it uses an electric heater to heat up the plates when it's done. So, electric heater is 1,000 watts inside the dishwashing machine. You got to be particularly careful with things. So, I'm just going to, I went ahead and showed you what was going on with trying to heat up the house a little. But I can't do that at night, so, that's totally out of the question, because the battery bank isn't even capable of doing this for, I could run this for 3 hours at night without turning it off. Now the question is, how many kilowatt hours does it use for 3 hours with the fan running? And I can't answer that question because it's got a thermostat and this thing turns on and off over a period of time, so it's not continuously running 3,000 watts. 1,500 watts. It turns on and off over a period of time. So, my question is, how much heat am I producing versus the kilowatt? And can I do it more efficiently somewhere else? Or, but I've got something coming called a kilowatt meter, and I'm going to do some tests with this to see how efficient, how long I can run for 3 hours with that thing. So, and if I could run for 3 hours on 5 kilowatts, that's, hardly turning on and off at all. But if I can run for like 6 to 10 hours on 5 kilowatts, maybe getting another 4 batteries would be able to run this thing. But we'll see. This is Philip 20 with solar power, electricity, and electronics. I'm going to holler at y'all later. Peace. Hello, ladies and gentlemen. Thanks for watching all the way to the end of the video. There's lots more content coming. Click the subscribe button below. Make sure you come back for more because there's great content always coming up every day in this channel. See you next time. Peace.